Thanks everyone for staying to the end, and thank you for joining. Thanks for the organizers, for BSides, for inviting me here. My name is Magno Logan, and today I'll be talking about hacking GitHub Actions, abusing GitHub and Azure for fun and profit. Before we start, just a little bit about myself. I promise there is no malware on this QR code as the previous presenter.
We believe you?
Yes, sure. But yeah, my name is Magno Logan. I'm originally from Brazil. I've been in Canada for over 5 years now. I'm part of the Nebula team, which is a cloud and container security research team inside Trend Micro. Also based out of Ottawa, as I mentioned. I also have a blog called Katana Security, and I'm a partner at Go Hacking. It's a cybersecurity training company out of Brazil. So just to start, I'll show you some pictures and ask if this is Canada or US. Canada or US? Maple syrup? Canada. Hockey?
US.
Debatable. Canada. Milk in a bag.
Ontario.
Yes, good. Sorry they were all Canada, I know. It's just to get your attention, and of course to make you probably raise your awareness to the speaker as well. So sorry about that, and yes, we tend to say sorry a lot. I'm getting used to that to get my citizenship as well, so yeah. But yeah, as I mentioned, just to start, I'm a partner at Go Hacking, which is a cybersecurity training company, and one of my trainings is about secure coding and DevSecOps. We're launching our training. They are live and online, and we're launching this training and other ones in English as well. Primarily, we are based out of Brazil, as I mentioned. So, if you want to learn more, it's a 40-hour training around secure coding, static analysis, dynamic analysis, and GitHub Actions as well, but in a builder kind of sense, how to build your pipeline using GitHub Actions. So there's that. And also, before I start, I like to give back to the community in a way, and the way that I do that nowadays, it's basically helping people either get jobs or transition into their IT or cybersecurity career. So if you reach out to me, if you want me to review your resume, your LinkedIn, or if you want to do a mock interview, all completely free, no strings attached, just reach out to me and we can talk about it. I do that, and I've been doing that since the pandemic, since COVID, for mostly Brazilians back in Brazil, but now I'm expanding that to anyone interested as well. Okay, so this is what we're going to cover today. Who here has heard about GitHub Actions, actually? Okay, a few people. Who here has heard about GitHub? Okay, good. So yeah, I'm going to give you an overview of GitHub Actions, how it works, the syntax, and what you can use it for. And then we're going to dive deep into the security part and the research that I did during my time at Trend Micro, and doing this kind of focusing on exploiting or how attackers can abuse GitHub Actions for malicious purposes, and how they're abusing it today to basically make free money. So we're going to talk about malicious actions, like how can someone deploy a malicious actions to the marketplace and compromise others, some attacks and abuses, different options there, and of course at the end I'll showcase some countermeasures, and I'll give you a preview of a tool that I'm developing, which is basically a static analysis for GitHub Actions, so that it can analyze your GitHub Actions and detect if there is something suspicious or malicious in your YAML files. This talk is based out of these two main articles that I published on the Trend Micro blog. So the first one there talking about the runners, which are the VMs that run inside Azure, as GitHub is owned by Microsoft. Everything runs on Azure. And the second one here to the right, it's talking more about the crypto miners and how attackers are abusing this free cloud service, compute service, to mine cryptocurrency. Okay, so here's our overview. Every action, every GitHub action, think about GitHub action as your CI, right? So similar to Jenkins, which is more popular, but it's probably not as safe. Let's say there is an event. So an event happens in your repository, in your application code, and that triggers your action. That triggers your workflow, right? So an event inside your repository, it can be like a pull request, any changes to a file, it can be a commit, anything. So there is a list of events in the documentation there. I don't remember everything out of the top of my head, but some of the main events, it can be even triggered manually. So workflow dispatch, for example, you can trigger your pipeline manually, just like any CI/CD tool. What happens when the event is triggered? You have the runner is deployed. Technically, it's not deployed. The runner, which is the VM running on Azure, it's already there. So it gets assigned to run your workflow. So at first, when I was doing this research, of course, I didn't read the documentation. I went straight to like hands-on, and I thought it was containers, right? So I thought, okay, it's run so fast because when I start my action, it's already assigned and it's running my commands. But no, it's a VM. But it's not spun up as I start my workflow. It's already there, but it gets assigned. So Microsoft, Azure, GitHub, they already have like some VMs ready to run your automation, which is interesting. So every runner, think of runner as VMs. Every runner will run jobs, and jobs are a set of steps or scripts or commands that you can define in your workflow. And your workflow, it's basically a YAML file that you describe, you define, and you store that inside your application repo, right? And there's a specific location for that workflow file, which is .github/workflows with an S. If you forget the S, it doesn't work, believe me. I had this problem before. But yeah, inside your job, as I said, you can run different actions. And actions, this is where it gets interesting. Actions can run other actions. So my action can call another action or a third-party action, right? So remember that this is going to be a problem later. I can also run scripts like a shell script if I'm on Linux. I can also run PowerShell if I'm on Windows. So what's interesting about GitHub Actions, first, that it's free for any GitHub user today. Of course, there are limits, and if I'm not mistaken, it's 30 hours per month per user for the free version. And you can deploy, your runners can be Linux, macOS, or Windows. So you can have these free options, right? The Linux is Ubuntu one, but yeah. So in this example here, this diagram, we have another runner, which means that I have another job. So another VM will get assigned to run this automation, this job. And by the way that it's being demonstrated on this diagram here, you see that there is a connection between the event runner 1 and runner 2. What that means is runner 2 depends on runner 1. So runner 1 needs to finish completing all the steps here from step 1 to step 4 for runner 2 to start doing their action. That means that there is a dependency. So technically, when you have that, the output of the job 1 probably will be the input of job 2, right? So you can have that. That's not mandatory. You can have jobs and runners running parallel as well, but also because of the limits, there is a limit on the amount of runners that you can have running parallel, depending on your license from GitHub. Any questions so far? Feel free to ask questions. This is the last talk, so ask away. One of the reasons I believe for the such great success of GitHub Actions, because it's getting a lot of attention lately. Most people that are, and most people in organizations that are on GitHub, they're either using Actions today or deciding to move to GitHub Actions instead of their own CI, because it takes away that need to maintain a Jenkins server and maintain it up to date and updating plugins from Jenkins, which is a pain, for example. So one of the benefits is the marketplace. As I said, you can run actions from someone else. So where do you get those actions? That's on the marketplace. The GitHub Marketplace for actions, for example, and this number is already outdated. I got tired of updating this slide because every time I present about this, the number changes, but it's almost at 19,000 today. I just checked. So anyone can write their own actions and publish to the marketplace. And the problem is that there is no security verification, there is no validation of whoever publishes that to the marketplace or whatever is inside that action, that YAML file, that automation that you make. You can say, oh yeah, this is a automation to build your Java application, but then there is a backdoor inside. There is no verification. GitHub does nothing around that. Okay, remember that. So here's just an example of an action that I got from the Nuclei DASCAN. It's used a lot today by bug hunters as well to validate and find bugs. But let's just understand the syntax here, because this is going to be important when I start showing you the malicious actions or the abused actions as well. So first we have name, which is the name of your action. That's pretty self-explanatory. But then you have on. The on directive, it's going to tell you when your action is going to run. So here I have two on directives. I have the schedule, which is based on the like the cron tab for Linux, but same way, right? So I specify there, and I have the workflow dispatch, which means that action can run manually. So anyone that has rights, that has the permissions inside that repo, they can go there and click start this action, and the pipeline will run. That might be necessary, for example, in this case, because you have like periodic scans, but maybe your scan didn't run, or you want to run a standalone scan, for example, an ad hoc. That's why you would need the workflow dispatch. Then you have jobs, and in this jobs directive, you only have one job that's called nuclei scan or nuclei scan. And you see that the directive runs on. That means which OS, which category of OS your runner will be. So I can have the Ubuntu latest, which is the latest version of the OS for GitHub Actions. It's not the latest version of Ubuntu overall, but only for GitHub Actions. And then you have Ubuntu latest and macOS latest if you're running the runners provided by GitHub. You can also run deploy your own self-hosted runners, but then you're paying for it. Steps. That's where my automation, my workflow really starts. So the first step there, it says uses actions/checkout at v2. What that means? That means it's using a third-party action, actions/checkout. Where's that code coming from? It's coming from a public repo from inside GitHub, github.com/actions/checkout. You can check that code right now. It's public. All GitHub Actions code are public. They should be public. And the v2 is just a version of the release. So you can specify that as well. So this is a third-party action. This one specifically, the actions username or organization, this one is maintained by GitHub. So everything that inside actions username, it's maintained or published by GitHub. But then you have a second action here with the name nuclei-scan. It uses project discovery nuclei-action at main. Now that's another third-party action from project discovery, which is the company that owns nuclei, and that's actually your automation, your scan, your validation, right, to check the application for vulnerabilities. It's going to run here. And you also have some parameters there with target example.com. That's basically the URL of your application. It can be an IP address, right, if you have like a development or QA environment. So that's also a third-party action. So if I stop there, if my automation runs, my scan ran, how do I know, how do I get the results? How do I get the scan results or the logs for the scan? The problem is that after the workflow is finished, I don't have access to that runner anymore. That VM that was deployed on Azure to run my automation, it's only available during this automation. Once that's done, it's killed. I don't have access to that anymore. So if I need to upload something that was generated during this automation, I need to specify that. I need to explicitly tell the action to upload that back to GitHub. And that's basically what it's doing on these two last actions, two last steps here. A workflow artifacts. The first one is uploading the nuclei log. So if there is something wrong with my scan, I need to check the logs. That's the first one there. Actions upload artifacts. And the last one is the results. So it's a .serif file, which is a common for security tools, usually static analysis, but nowadays dynamic analysis as well, basically with the findings from the nuclei scan. Because if I don't upload that, and that's going to be available on my GitHub repo, if I don't do that, I'm not going to be able to see the results. Any questions on the syntax of GitHub Actions? Okay, good. Okay, so what are the problems here? Some of the vulnerabilities, and this was when I started doing this research back at the end of 2021, there was only basically one reference, which was the GitHub Security Lab website. I didn't find anything else into 2021 when I started doing this research. So the three main problems that they listed was, first one, pull requests from forked repos, aka pound requests. What that means was that people were forking a repository, they were changing the YAML file for the GitHub action to mine cryptocurrency, and then they were sending the pull request back to the original creator of that repo. And so the automation was running when they sent the pull request, the automation started running, and it started mining cryptocurrency, but the bad user was the victim, the original creator of that application of the open source repo, and not the attacker, right? And so GitHub stopped that in a way, enabling a feature that for someone to send a first pull request to a new repo, to run the actions, they need to be approved. So I'm going to talk about that in the countermeasures, so that it's this attack is kind of prevented right now, because by default this is disabled. But there were like users forking like hundreds of repos, changing their YAML files, and then send it back to the original ones. There is also the problem of command injection via untrusted inputs. So if you're dealing with the GitHub action, there are some fields inside your action that can be controlled by the user, so should be considered untrusted. Validating the inputs is some basic application coding, secure coding hygiene, so you need to be aware of that as well. But the third one, that was kind of the main focus of my research, is, okay, what happens, because we're always talking about supply chain attacks. Okay, what happens if I create a malicious GitHub action, I make it seem legitimate, and I publish to the marketplace, and someone starts using that? What could happen? So that was kind of the main topic of the research that I'm going to talk about today. So this is just an example. I know it's not great because of the lighting, but I have other examples here. This is the example from the forked repos. People were basically changing the YAML code to mine cryptocurrency, and I have other examples there. So, and sending it back to the original maintainer. Okay. Here we're talking about abusing Windows runners. So the runner, the virtual machine that's running inside Azure. What's happening here, the last line is kind of, okay, the more interesting one, more important one. That's when I'm running the node.exe file, which was inside that malicious repository. And it's basically a crypto miner, right? A Monero crypto miner. You can see there XMRig, the pool, and the username for that mining operation. But the first red arrow there, uses nick envision / retry at v2. Is Nick here? No? Nick? Okay. That's a third-party action, right? We talked about it. Uses nick envision / retry. But that's a legitimate action. I checked the code for the action. It's legitimate. It's just to retry your action if your action fails. Retry your automation, retry your workflow. So attackers are already leveraging legitimate third-party actions for their mining purposes. So that's happening today. Yeah, so yeah, I checked the code. As I said, any GitHub action code is a public repo. You can check the code. It was just redirected to a new name there, but it's the same one. So it's like, okay, retries an action step on failure or timeout. It's not malicious, right? They're using to kind of save time, and it looks like the attackers know more than us around the topic of GitHub Actions. And of course, the node.exe file that was there doing the crypto mining actions, it's malicious, right? Just checking it on VirusTotal, just an example. Yes, it's malicious. Some other examples here with Windows runners. So still on the topic of Windows runner, I'm not sure if you can see very well there, but now they're using PowerShell. You see the invoke, web request, expand, archive. These are all PowerShell commands because it's running on a Windows box. And if you look at that code, Captain Crypto, that's the name of the action there, I found the exact same code on over 100 repositories. So all of these and 100 more were the exact same YAML code. Exact same. So attackers were creating different usernames, automating their attack, creating different repositories, and mining cryptocurrency for free, right? Getting money for free. We've reported this to GitHub. It took them about 8 months to reply back to us, and some of these are even not taken down yet. So I don't know. I don't know what's going on there. But yeah, same example with Linux, just different approach, different commands. But yeah, at the end, it's downloading the XMRig and expanding the archive and starting the crypto mining attempt. What's interesting is that every job can run for, every job can run for up to 72 hours, and every step can run for up to 6 hours. So that's why they need some automation, they need to restart it. There are limits, especially on the free accounts. Another thing that's interesting, but it's not on this example, this is a specific example here, is that the crypto miners know that GitHub and Azure are onto them. So in some of the instances that when they start the crypto mining, there is a command on the XMRig to limit the CPU usage. So they specifically limit the CPU usage to 70% to avoid being detected. Right? Okay, the CPU is not 100. Okay, it seems normal. Everything is fine. Let me get my free money. Right? And recently, more recently, I found abusing macOS runners, which might not seem that common, but yeah, it is. So there was this repo here saying, since the core book, Hackintosh, whatever. I couldn't read it. It's only, I believe it's Chinese, so I couldn't read it. But I can read the YAML file. They should be the same. So if you look at the YAML file, you'll see that down there at the bottom runs on macOS latest, and here it's basically same thing, right? Giving the execution permissions to the XMRig and run it with the specified configurations. And of course, the XMRig no fee, this is a Metro binary. And I'm not an expert on doing Metro reverse engineering, so I asked a few friends to take a look. But yeah, just VirusTotal as well is telling me, yeah, this is not legitimate. This is malicious binary. Okay, so if you go to a repository and you go to their Actions tab, you can see, if you have permissions, of course, you can see all the history, all the automations that they did, if there is a limit, of course. But if you see something like that, if you see this kind of red banner, red tag there, means that the GitHub Actions is currently disabled for that repo. It's probably because they were doing something suspicious or malicious inside that repo. The problem is that GitHub only blocks, only disables the action on that specific repo. So if the same user creates another repository, they can run actions again. I don't know why. That's how it works. What is interesting during my analysis was, okay, what's running by default inside those runners, right? There are some services, there are a bunch of tools that comes pre-installed inside those VMs because, right, it's a build VM, right? You need to have, Java, Python, I don't know, Docker, you need to have all that stuff pre-installed because you don't need to download it every time you run your automation. But what's interesting is that there were 3 web services installed, and one of them was active by default. So 2 of them were Apache Web Server and Nginx. Those were disabled by default, but there was another one called MonoXSP Web Server. Has anyone heard about this web server? It's very, very old. It's originally developed in ASP.NET, whatever, for Microsoft, but they ported to Linux. This was inside the Ubuntu machine, and it was enabled by default. So yeah, you can't find it very, a lot of them exposed online on Shodan, but it was there. This is from the documentation from the GitHub Actions. So you see that the MonoXSP4 is active and running on port 8084. So I said, okay, what the hell is that? I don't know. So I start digging, I start doing some analysis as well. This is from the nmap scan. Okay, yeah, this is getting 500 errors. I was able to download the code finding the version of the MonoXSP. It's public, it was an open source project. But even running some static analysis to find vulnerabilities on the web server itself, because it's so old, there are no tools or rules to specifically check for that. Interestingly enough, in the latest version now of Ubuntu, this MonoXSP is removed. It's not installed anymore, and it's not enabled by default. I think it was something related to either like a health check or heartbeat that Azure used it for, but I'm not sure exactly. I couldn't find out the real reason, but it's there, and I talk more about it on my blog post as well. Okay, so the malicious GitHub Actions. I talked about anyone can post actions in the marketplace. It's kind of I don't know. It's basically, there is no validation, there is no verification, right? So you need to treat anything that you use from the marketplace, you need to treat as a third-party dependency. Just like you do it with your libraries from your code, from your application, third parties, you need to treat actions as a third-party dependency. There's only one thing that GitHub does that kind of gives you some sense of, I don't know, trust in that maintainer, that person or organization that's publishing that action, and that's that blue check mark there with the creator verified by GitHub. That's not like Twitter check mark that you pay for it. You need some domain validation there, but that's all they're doing. They're not checking it for security. They just validate the company, if the company really owns that domain, I think, and that's it. So there is no security checking involved as far as I know. But as I said, if you see the third-party actions being called actions/checkout or actions/setup node, you can go to the URL, right? The URL is that one, github.com/actions/checkout, and I can check that code if I understand it, if I have a tool to help me out to scan that code. Sometimes the action code can be just a shell script or can be like a JavaScript, Node, whatever. So I can do some static analysis there as well. So what kind of attacks can I do if I deploy a malicious action and either on my own user, or if I make someone else use my third-party action that I publish on the marketplace? I can run nmap scans inside the Azure internal network. I can do the reverse shell from the runner to external server. And I can use that runner, it's a VM. I can use that to pivot and use to attack other targets, either inside Azure or even outside, because it has outbound connections. So the victim will see, oh, the IP address is coming from Azure, but they will never know it was me unless they request Azure for the logs or something like that. So here's just an nmap scan. I know it's not great because of the lighting, but 5 ports were open by default. 22 SSH, 80 HTTP 443, 3389 RDP, and the 8084 the mono XSP server, right? This was from the previous version, so it was there on every other. And I saw the first one is my own runner, and the other ones are the ones that are idle, waiting to be assigned to run the workflow. So I did this, and I can do the demo. I think we'll have time. Basically, what I did was, okay, what happens if I create a GitHub action that will connect back to my kind of C2 command and control server? Can I do that? So that's what I did. And I think we should move to the demo right now. Let's see. So hopefully that will work. Okay. So here's my, oops, it's not there. Okay, 1 second.
Good security.
Yeah. Maybe too much. Let's give it a minute. Okay. Let's see if I. Okay. Maybe I should switch to. Where is the appearance? Let's switch to the. Okay. Light mode. Okay. Guess that's better. And now. Okay, so this was kind of the basically one of the main repos that I used throughout my whole research. All the commits, all the stuff that I did, it's there if you want to take a look. But it's all there is. There is no application here. There is only the .github/workflows for my automations. And I have 3 YAML files, so anything inside this folder that has the .yml or YAML, GitHub will try to run. We'll think it's a GitHub action and we'll try to run. So the first one that I have here is just a demonstration for the GitHub Actions. Let me increase that font. Okay. Okay, so I'm deploying on Ubuntu latest, and I'm just running some Linux commands here. Okay, and you can see that it's on push the directive, so any changes to this file or anything else in that repo will trigger the automation. So that means if I edit this file, and let's see, I'll remove just the New York here again, besides Buffalo, commit to main, sorry for any developers here. But once I do that, if I go to my actions tab, I see because of all the actions there are running on push, all of them trigger at the same time. So that's okay. But the one that we want to take a look at is this one, hello world.yml. Let's see. It's completed already. And this is kind of the console output, similar to Jenkins if you're familiar with. So these are the results. ID, uname-a, env, and hello. So I see the ID here. The username is runner, and inside the Docker group, I can even sudo to that runner as well. This is the uname-a, so you can see that it's a Linux running on Azure, and then the environment variables. There is a ton of environment variables. There is one that it's interesting here because it's math. You see the 3 stars. I can talk about that later. And down at the bottom here, you see the hello besides Buffalo, okay? This is just a simple example. But now, the funny one, the interesting one that I was talking about earlier is, okay, the second one here. The NC or netcat. So same way I have on push, jobs, runs on Ubuntu latest besides Buffalo. And what I'm doing here, can ignore this, let me add it. Basically what I'm doing here is downloading netcat from source, building and running netcat, and this is the IP address for my C2 server, whatever you want to call it. And that C2 server is on AWS. So that's here. Let's see if I still have connection. Yeah. 21, that's fine. Yeah, 21. Okay. So that's my instance on AWS. The runner is running on Azure. It will connect to my instance, my EC2 there. Why did I build netcat from scratch, from source? Anyone? Because the one that is installed on Ubuntu doesn't allow me to use the leverage -e functionality. There are other ways to do that, but I decided to go this way. It seems simpler. I just want to validate my assumptions. Okay, so I changed the file there. Let's see on the GitHub Actions. See, this one is running, so that's the one, and c.yml. And it's going to keep running because it's doing the reverse shell to my EC2, right? It's going to keep running here until I stop. So you're going to see, yeah, running, and hopefully it will work. Let's see. Yes. Okay. -a. So you see, I'm inside my, let me increase the font here. I'm inside my EC2 on AWS, and I got a shell there from the runner. So now I can run, because technically you're not allowed to run interactive commands on your runners, right? You have to change everything, all these commands, you have to set it up on the YAML file, but now I can. Now I found a way to speed up my research, because now I can do that interactively, right? For the 6 hours timeout that I have, so that should be enough time for a good work day. That's enough. But yeah, it's there, environment variables and all that stuff. And the one that I was talking about, let's see if it's here. No, it's not there. Yeah. Okay, but it's mass. I'll talk about that later. There is a GitHub token that it's there. It should be there. Okay. So now, because I stopped, I exited, so now my actions also failed, stop. That's fine. But then, okay, what happens if now I'm calling the action directly, right? So this is, okay, my action is calling my C2 server directly. But what happens if I create a separate repository with that backdoor, that reverse shell, which is here? This is my kind of me creating a third-party action, right? There's just the fake GHA, is just the readme, the action.yml, and the backdoor.sh, which is basically the same command. And if I run that now, let's say if I run that here, let's go back to DHA test, and I have another one, that's the marketplace.yaml. So you can see here that, let's see, okay, so now my GHA-test would call this third-party action, right? This is the same way that we're calling other third-party actions. So every time someone calls this fake GHA, they would, I would get a reverse shell on my server, my C2. So I could do something there. I could do the crypto mining. I could do anything I want. I could also make it less suspicious because, yeah, it's a fake GHA. It has like the name of the file backdoor.sh. I would probably not do that. One thing that I didn't do though, I didn't publish this to the marketplace because of legal reasons and because I probably would be without a job today. But yeah, I was not allowed. I asked them, even if it was just to do something like an echo hello, the legal team said no, right? So we avoided doing that. But since this is a separate repository and I'm calling this from another repository, it's the same way. It's a third-party action. So that would work as well, and that it did work. So it would get a shell in a similar way. So let me go back. Any questions? Yeah, go ahead. Sorry.
As an end user, do you have any way of protecting the outbound network request? When you put a network policy that says, like, my owner shouldn't access the internet at all?
I found out about it at NorthSec Montreal a couple weeks ago that there are some ways to harden your runner. So you can harden it. So there are some third-party actions and stuff that might be able to do that. But by default, as far as I know, no. Okay, so yeah, basically this is what this slide is showing. If the demo didn't work, the reverse shell. So I thought to myself, okay, since I can do the reverse shell from the runners to my servers, I can also issue malicious commands from my servers to the runners, right? So I could start the crypto mining, I could do other stuff, I could even collect all the environment variables. There might be tokens there, and there will be if you're using some sort of automation, not just the GitHub token, which was the one that was masked with the 3 stars there. It's the token that gives you permissions from the runner to your repo. So by default, that used to have write permissions. So if someone grabbed that token from your runner, they would be able to change anything in your repository. Now it's read only, but still, if you can give the right permissions if you need to, if you have to. And yeah, I can use that runner. So for 72 hours, I have that VM, the free version, the limit for the free version. I have the VM to do anything I want. So I can even attack other targets on Azure or outside of Azure. So this is the slide for the third-party action, the one that I didn't publish to the marketplace, but that I showcase right now. Same thing, backdoor. I make it very clear that this is a malicious action, right? It's public, it's a repo, but it's not on the marketplace. So if someone went to my username, my repository used, that's their fault. But yeah, same command there. Just another example. Okay, but how do you, like, as a user, as a developer, how do you check if your actions or third-party actions are malicious or not. There is no way today, there is no scanner or static analysis tool, as far as I know, that can scan your YAML file and detect something suspicious, something malicious. So what I'm presenting here today, this is something new for you guys. I've presented this talk before, but this is the first time that I'm talking about a tool to analyze your YAML files, to scan your YAML files from your GitHub Actions and find something suspicious or malicious. So I can do the demo, but let me just explain how it works. Basically leveraging OPA, which is Open Policy Agent. It's an open source tool, cloud native, from the CNCF, the Cloud Native Computing Foundation. I can use the OPA syntax, which is called Rego, or Rego language, to write rules to analyze files. So basically I wrote, these are kind of all the rules that I have today, 6 rules to detect crypto mining, malicious commands, or secrets, or third-party actions. And by using these rules, and I'll do the demo in a second, I can scan, I can run it against my actions and detect. The first one is detecting a malicious Linux command, and the second one means that, okay, this action is calling third-party actions, right? So it might not be malicious, but it's still a problem because I'm calling third-party. So let me go to the demo again. Let me do this just to know that I'm not lying. And I still haven't published this project as an open source repo yet. It's still private, but I should publish that very soon. I'm just writing a few more rules to to have it as a kind of, I don't know, make it useful. So let me increase the font there. So yeah, this is just the, oops, still not working. Takes some time. Let me see. Okay. So yeah, these are the 6 rules that I mentioned. And let's see, running commands, running suspicious commands Linux. So if I do that, and I'm just gonna prove that using OPA, there is the, how do I validate that? Is using OPA eval function. And basically what I did was I basically converted the YAML file to a JSON, because that's how OPA interprets data inputs. And I have my query here, the query.rego is kind of the rule that I created to validate this. So when I run it here, let me increase the font a little bit. So you can see that by analyzing the YAML file, which was converted to JSON, it found the suspicious Linux command. Like I'm doing a wget to an external source inside my runner. So that might not be suspicious. That might be suspicious actually. And I have one for crypto mining. I have one for secrets, for example, for third party as well. So let's see, CD using third party action and the same command. So yeah, it means that this workflow is just an example, a testing action. But you can see that this workflow, this action is calling 2 third party actions. The action/checkout that we saw in the beginning, and then the sneak/action/node, because it's for running a sneak. It doesn't mean that this is malicious, but it's calling a third party, right? It's something to be aware of. It's kind of a, I don't know, informational, could be. But yeah, the plan is to release this. I'm calling this GitHub Action Sentinel for now. We'll see. And I should be releasing that as an open source pretty soon. Okay? And with that, we're almost out of time. So some countermeasures. Oh, wait. Okay. Yeah, some countermeasures for you to take away from this talk, and if you're just using actions as a developer, only using actions from trusted creators, but be aware that trusted creators doesn't mean that it's being validated for security. Make sure that you set the right permissions to your actions, like the least privilege principle, right? If you don't need right permissions to that token to modify stuff on your repo, don't give it right permissions. Do not run actions from forked repos. That's kind of disabled by default now from GitHub. And of course, protect your secrets. You're going to probably need to add more secrets, more tokens inside your actions. There is a way to do that in a safe way from GitHub, but also protect those, because if someone captures those secrets, they're usually API tokens and tokens that might give access to other tools that you're using, so that could be a problem. So just some screenshots here. If you're not using actions in any way in your organization on your repo, you can just disable it. That would be the best way to do it. And that's the one from the forked pull request. So for first-time contributors, someone contributing to your project for the first time, it will not trigger any action, will not trigger the automation, avoiding that problem of forked pull requests. And yeah, that's it. I hope you enjoyed this talk, and I'm open to any questions right now. Thank you. Yeah, go ahead.
What should Microsoft be doing to keep it from, not from a security perspective, but a abuse protection perspective? They said anything about crypto miners, they're okay with it running on their hardware. I'm surprised that was all.
Okay. Yes. So what Microsoft is doing around the abuse of the runners and crypto mining, I think not a lot. From what I've seen, it's basically a whack-a-mole. You know, they try to block people, block users, but people create. It's a free service, right? They can create a free account. I just generate another fake email. I just need to bypass their CAPTCHA, which is not that hard, and then I can start mining again. So from what I've seen, it's just a whack-a-mole. I don't see them doing from an external perspective. I don't know. I have a few friends that work in the GitHub security team there, but they couldn't disclose more information. But as far as I know, I had this idea for this tool for analyzing malicious GitHub actions in 2021. And GitHub already listed that they were doing something with their CodeQL for scanning YAML files, and up until today, they haven't done anything. So I'm not sure if it's budget, priority, whatever. So I decided, okay, I thought that GitHub would create something like this, and okay, my tool would be useless, but they didn't for 2 years basically. So I said, okay, I might as well get it done. Then maybe that will motivate them to write some CodeQL rules. So yeah. Any other questions? Okay. I'll be around until the end of the day. We're pretty much wrapping up, so thanks everyone.